I'm Patrick Thompson, founder of Inkstone Software, a consumer app company in Portland, Oregon. In this talk, I'm going to discuss how we can use AlpineJS with Phoenix LiveView. We will start with the discussion of LiveView and JavaScript, give a short introduction to AlpineJS, drill into how LiveView and Alpine code can interact with each other, detail 3 real-world examples, and wrap up with some resources where you can learn more. So why are we even talking about JavaScript and LiveView anyway? Wasn't the whole idea of LiveView to get rid of JavaScript? To be able to create reactive server-side web apps without writing any JavaScript? Well, yes and no. LiveView allows us to create server-rendered web apps that have the reactive features of a SPA application, but without the complexity of a client-side framework such as React, Vue, or Angular. That said, JavaScript is still super useful on the client. For example, for client-side operations that don't require a round trip to the server, for UI operations that depend on the rendered size of elements, and for UI transitions. Ironically, for a framework that was supposed to get rid of JavaScript, LiveView has excellent support. This is through its hook mechanism and its integration with AlpineJS. LiveView allows you to create JavaScript lifecycle hooks. Hooks are objects that can be attached to DOM elements and get called throughout the lifecycle of the element. Callback functions are called on the hook object when its associated DOM element is mounted, about to be updated, about to be destroyed, disconnected, and reconnected. Hooks allow JavaScript code to interoperate with LiveView. Hooks have access to the element that they are attached to, as well as window and document. Hooks can push events to the server LiveView using push event and push event to, and hooks can receive events from the server LiveView using handle event. Hooks are just regular JavaScript objects with some special properties. As such, they can be registered with window. We will leverage this later to access hook functions from AlpineJS code. LiveView JavaScript hooks take us a long way, but sometimes we need more fine-grained control. That is where AlpineJS comes in. AlpineJS allows you to embed JavaScript code in your HTML markup. For that reason, it is sometimes called Tailwind for JavaScript. Alpine complements hook code. It doesn't replace it. In fact, the complete implementation is often a collaboration between Alpine and hook code. AlpineJS is a simple, lightweight JavaScript framework made by Caleb Porzio, the creator of Livewire, a LiveView-inspired framework for PHP Laravel. As such, LiveView and Livewire have similar programming models, and they both use Morphdom on the client to update the actual DOM. Caleb created AlpineJS to be used with Livewire to handle small interactions that don't require a round trip to the server. Alpine was literally built for something like LiveView. As Caleb says, it's a JavaScript Swiss Army knife for client-side code. Alpine is a front-end development framework for adding JavaScript behavior to your HTML markup. You can think of it as a replacement for jQuery and vanilla JavaScript. It is useful for things like drop-downs, sidebars, tabs, expandable UI elements, image selection, scroll detection, and smooth UI transitions. Alpine is the only JavaScript framework to be integrated with LiveView. Usually when using JavaScript with LiveView, you need to fence off the parts of the DOM that are modified with JavaScript code, using phx update = ignore. Otherwise, LiveView will reverse any changes made by the JavaScript code. But this isn't the case when using AlpineJS with LiveView. This is because Alpine processes nodes after LiveView does, giving Alpine an opportunity to make its changes to the DOM without getting in the way of LiveView. To prove it, here's some LiveView code intermixed with AlpineJS code. It tracks a LiveView count assign, shadowing it in an Alpine data property, and adds and removes DOM nodes as the count is incremented and decremented. To enable AlpineJS interop, you need to initialize your live socket in app.js with the DOM property, as shown here. Let's go through a quick introduction of AlpineJS. This isn't meant to be a full tutorial, but just enough so you get a flavor of Alpine, and also so you can understand the examples that we'll go through later. Here's a simple AlpineJS example. This is a counter component with increment and decrement buttons. It displays the count, and it displays when the count is greater than 100. Alpine is added to your markup using X directives. There's a set of X directives that we can use to write our AlpineJS code. It always starts with an X data directive. This declares the Alpine component scope, and you can give it a JavaScript object with a set of data properties. An optional X init gets executed when the component is initialized. Here we are using what's called a magic property, the watch magic property. It watches for changes in count, and when count changes, this function gets called that you declare here, and it's passed the current value. Here we're just displaying a log message. Here we are using the xtext directive. This will replace the inner text of this span of this element with the result of a JavaScript expression. In this case, the JavaScript expression is just the count data property. xShow is used to show or hide an element based on the Boolean result of a JavaScript expression. So here we're just looking for the count being greater than 100, and then we'll display this header. xOn is used for creating event handlers. So here we're creating a click event handler, and when this decrement button is clicked, we will decrement the count. And this is an alternate @click is an alternate representation of a click handler, alternate syntax for creating event listeners. So where you see that's the same as xOn, and here we're just incrementing the count. Alpine has 14 directives that are used as HTML attributes. xData declares a new Alpine component scope. xInit allows you to run some code when the component is initialized. xShow allows you to show and hide an element based on a Boolean expression. xBind allows you to set attributes on an element. xOn allows you to create event listeners. xText allows you to set the inner text of an element. xHTML allows you to set the inner HTML of an element. xref allows you to name an element. xif allows you to conditionally add one or more elements to the DOM. x4 allows you to add multiple elements to a DOM. xTransition allows you to create enter and leave transitions for an element. And xCloak allows you to hide an element until JavaScript is initialized, which is useful for us using LiveView because on the first render we don't have JavaScript. So we typically use xCloak with our AlpineJS components. There are 6 magic properties in Alpine, and these can be used within JavaScript expressions. So element refers to the root component where you define xData. Refs allows you to refer to those xref attributes. Event allows you to access the event properties within an event handler. Dispatch allows you to dispatch a custom event. Next tick allows you to execute an expression after the current update. And watch allows you to watch for changes in Alpine data properties. Let's look at a real example. This is a simple drop-down. You can see when we click on the avatar, the drop-down is displayed, and if we click again, it disappears. And here's our implementation using Alpine. So we initialize our Alpine component scope using the xData directive. Here we have one data property, open, which is initialized to false. Our button, which is just the avatar, has an event listener. It has a click handler, and all it does is it toggles open between true and false. xShow will determine whether this element and all child elements are displayed. So if open is true, this will be displayed. If it's false, it will be hidden. We use xcloak to hide the dropdown on the initial render. And then we have a series of xTransition directives. We have the enter transitions and the leave transitions. So enter just sets up the transition. So the timing function is ease out, and it has a duration of 100 milliseconds. And then on start and end, we transition the opacity from 0 to 100 and the scale from 95 to 100%. On the leave transition, we use the ease in timing function and a duration of 75 milliseconds. And we transition the opacity from 100 to 0 and the scale from 100 to 95%. So we have a nice fade out with a little bit of movement. And here's the drop down itself, which will be shown and hidden based on xShow. Next, let's look at how we can communicate between our Alpine and our LiveView code. Luckily, it's not as dangerous or as difficult as tight wiring across a canyon. In fact, it's quite easy. In this section, we'll go through a few techniques for how we can do that. We can communicate back and forth between Alpine and our JavaScript hooks and between Alpine and our server LiveViews. From Alpine to our hooks, we can send custom JavaScript events, or we can call hook functions directly. From our hooks to Alpine, we can send custom JavaScript events. From Alpine to our server LiveViews, we can call a hook function from Alpine, and then from the hook function, push the event to a LiveView server. Or we can call push event directly through a hook that is registered on window. From our server LiveViews to Alpine, we can push event from LiveView to a hook, and then send a custom JavaScript event from the hook to Alpine. Or we can shadow LiveView assigns in our Alpine data properties directly. Let's look at some examples of each. Here we're sending a JavaScript event from Alpine code to a hook. We're using the dispatch magic property to send an event within a click handler. We give the name of the event and then any properties we'd like to send with it. Within the hook, we're adding an event listener with that event name. And then when we capture the event, we can pull out any data from that event. Here we are calling hook functions directly, which is easier than sending events because you don't have to set up event handlers. To do that, in our hook, we need to register our hook with window. Once we do that, it'll be available globally from our Alpine code. So here within our click handler, we're calling counterhook, which we registered with window, and calling a function on that hook. Remember, hooks are just regular JavaScript objects, and they can have functions beyond the typical lifecycle functions that we define on hooks. So in this case, we're calling these functions directly from our Alpine code. Going from hook to Alpine, we can send custom events that can be handled within the Alpine code. So here's a hook. We are creating a custom event. We give the event name and then any data we want to go along with that. And then we call dispatch event on that element. That element is whichever element that we registered the hook on. So the event will go to this element. Here we're capturing it, so x on and then the event name. So this is the same event name that we used up here. and we can pull out any of the details from the event. Going from Alpine to LiveView, this is a two-step process in this example. So we're calling a function on a window registered hook, and then within that hook function, we're doing a push event to the server. So we go from the Alpine code to the hook, and then from the hook to the LiveView, where we can handle that event. We can also call push event and push event 2 directly from our Alpine code. The way this works is we register a hook with window, and because all hooks by default come with push event and push event 2 functions, we can call this from our Alpine code through that window registered hook. So here in our click handler, we're calling push event hook dot push event and push event hook dot push event 2 directly from our Alpine code. Now going from our LiveView code to Alpine, one way to do it is we can call push event, which is new in 0.14. We can now push events from the server to hook code. So we can push an event, and it's called count updated in this case. In our hook code, in mounted, we can register an event handler for that event, and we are going to turn around and create a custom event that we will dispatch, and that event will be picked up by our Alpine code. So here we have a count updated event handler. That's what we called our custom event. And within here, we can access the data within the event itself. And finally, this is my favorite example. We can shadow LiveView assigns in our Alpine code. So we can see here in our xData directive, we're initializing the Alpine component with a count data property, and we're initializing it to a LiveView assign. Then we're displaying the LiveView assign, and we're also displaying the shadow count, and we can see they stay in sync with each other. I think the way this works is Alpine is watching for changes in the DOM. When it sees that count changes, it reinitializes this Alpine component with the new count. So it's interesting. We can actually change count from two vectors, from either changing the LiveView assign, or we can change it in Alpine code. A note, it doesn't work the other way. We can't change LiveView assigns from our Alpine code. Next, let's look at some real-world examples, starting with a read more, read less example. So this is where we have content that may be larger than the amount of space that we want to allocate for it on by default. In this case, if the content is larger than that size, we show a read more button, which expands the content to its full height, followed by a read less button, which closes it again to the closed height. So here's the code for it. Note, in these examples, we aren't going to be showing most of the CSS. So one, we can focus on the AlpineJS code, and two, because I use Tailwind CSS, which is somewhat verbose, and I'd never be able to get it on the slide. So here we declare our Alpine component with xData. We have show more. We default it to true. We have to set it to something. We have height, which we default to the closed height. And we have a new URL, which is used to determine whether we have new content, and we'll see how that's used below. We have our xinit section. Here we initialize show more according to the current content. So we're referring to the content div, which is down here, we name it with an xref. We call it content, so we can use the refs magic property to say refs.content.offset size. So this is the size of our content, and if it's greater than our default closed height, we will set show more to true, otherwise it's false. We also set up a watch because this content could be replaced with a live patch or a push patch. So we want to be able to recognize that. So new URL is set to the URI and handle params. So if that changes, we will notice and we will set show more according to the new content size. Here we have our description. We are on our div, we are setting the style max height initially to the closed height, and we're using xbind, which is a directive that allows us to set attributes on an element. So here we're setting the style attribute to we're setting max height to our height pixels, which is either the closed height or it could be the full height, depending on whether the content is open or closed. We're also using some Tailwind classes here to transition all of the transitional properties, which in this case is our max height. So this is what gives us the animation opening and closing the content with a duration of 300 milliseconds. Here we have our read more, read less buttons. Sometimes I find it's necessary to use if connected. Otherwise, you may see some artifacts that you don't want to see when it's not connected. That must have been the case here when I wrote this. Xshow determines whether the read more, read less button is shown at all, and it's set to show more, which we set it to whether the offset height is greater than the closed height. So when we have two click handlers, we have two spans, one for the read more link, and the click handler sets the height to the content height plus a little bit more. So once we do this, if the content is closed and you click the read more button, and the content will be closed if the read more button is there, then that will result in the height being set to the full height, and that will result in it animating open. Xshow is determined, whether this element is shown or not is determined by whether the height is equal to the closed height. So if it's closed, the height will be set to the closed height, and thus a read more will be shown. For the read less button, it's shown if the height is greater than the closed height. And what it does in its click handler is it sets the height to the closed height, which again will cause for the element to be, the size of the element to be set to the closed height, and it will animate closed. Next, we'll look at a modal example. Here we have a delete confirmation modal. We can see that it transitions in nicely and transitions out nicely. There are actually two parallel transitions going on here, one for the background and one for the modal card. They're slightly different. Here's one way we can implement it. We could use a LiveView show assign to conditionally add and remove the modal from the DOM. The challenge with this is when we remove it from the DOM, the leave transitions don't have any time to complete. The trick for handling this is to use a hook that defines a function that when it's called, it's passed the leave duration, and it sets a timeout, and when that timeout expires, it pushes an event to the server to close the modal, and that will change show to false, which will at that time cause the modal to be removed, and the transitions will have completed by that time, so everything will be good. So in our modal implementation, we set our hook. In our X data, we set open to false initially, And then in our exinit, we set a timeout with a timeout of 0 that changes open to true. And that gives us the transition from open being false to true that will cause for the transitions associated with our backdrop and our modal card to kick off. So we have some X transitions associated with this, with these two elements that I'm not showing here. But those will be kicked off when open transitions to true, which this set timeout does. We're using next tick here to set the focus for the right button to false. We're referring to the modal right button, which is down here. There's next ref that refers to this button, so we're referring to it here and setting its focus. We're setting up a watch, and we're particularly interested when open changes to false. When it changes to false, we will call our modal closing modal hook function, which will start the timeout. We have a keydown.escape event handler, so when you press the escape button, it'll close the modal. We have our xshow, which is set to open, and xcloak. In our modal markup, we have our backdrop, and that's we have our xshow set to open. Same for our modal card. And here we have a click away handler. So if somebody clicks away from the modal card, it'll close the modal. We have the body of our modal, and then our buttons. We're just showing the right button here. We can see we have a phx click handler, which sends the click to the server, and the server will do whatever it needs to do for that click event. And we also have a parallel Alpine click handler, which changes open to false, which will kick off the timeout that will eventually close the modal. And that's it. We could also implement this slightly differently. We have an alternate implementation here. The only difference really is that rather than conditionally showing the modal with a LiveView assign, we're using that assign in initializing open in xdata. So when we do this, Alpine will notice whenever show changes to false, and it will cause for the modal to be closed at that time. The primary difference between these two is when we are conditionally showing the whole modal, when show changes to true, it will send the entire modal down to the client. In this case, when show changes to true, the modal is already on the client. We're not conditionally showing it. So the only thing that needs to be sent is the value of show. Next, we will look at what I call a flash notice. It's like a flash alert, but it can be shown at any time. I found that the regular LiveView flash alert works great with push redirects, but it doesn't work with push patch. So I created a flash notice for those cases, or at any arbitrary time I want to show a flash notice. This is what it looks like after our delete confirmation modal. We will display a notice saying that the user was actually deleted. Look at it one more time. There it is. It animates in and out nicely. So let's see how we do this. To kick off the flash notice, we are going to push an event from the server to the client. This is a new feature in 0.14. It was originally created to push large sets of data, like map data, to the client without having to attach it to the DOM. But it works great for one-shot events like this. So we're going to push a flash notice event from the server to the client. It's going to be picked up in a hook handle event function. So it's waiting for this flash notice. When it gets that, it's going to dispatch an event, a JavaScript custom event that will be picked up in the Java script code in the AlpineJS code. Now let's look at the actual code. We create a put_flash notice function that works just like put_flash. It takes a socket and returns a socket, and it takes a notice kind and a message. And it calls our push event to push the event down to the client. And this is called from a handle info function. In our hook, we're handling the event, the flash notice event, and then we're turning around and creating a custom event. We pass in a kind and message and a timeout, which is set according to what kind of message it is. And we take that event and pass it to dispatch event on the element that this hook is associated with. Now in our Alpine code, we have our flash notice event handler. It sets a show to true that will start the display of the notice. It sets type according to the kind in the event. Type is used to set the background color of the notice. Xbind with class works slightly different than other attributes. You can conditionally add CSS classes according to one or more conditions. So here, if the type is error, we're setting the background color to red. If it's info, we set it to blue. We get the message, and then if there's a timeout, if the timeout is greater than 0, then we will set a timeout. When that expires, we will set show to false, so it'll automatically disappear after that timeout. And the rest, I think, xShow is, we'll show it based on show. And the message is displayed using xtext, which sets the inner text of this element. So it'll be set to message. And then our click handler sets show to false. And that's it. And that wraps up our tour of using AlpineJS with Phoenix LiveView. If you'd like to learn more, the README on the AlpineJS GitHub repo serves as a documentation. There's a free 1-hour Scrimba course that'll get you up to speed on Alpine in about an hour. There are 18 articles on Alpine on Hugo DiFrancesco's blog. There's an AlpineJS Discord if you have questions. You can find the full code for the Modal and Flash Notice examples on GitHub. I have a couple articles on using Alpine with LiveView on my blog. And I am P. Thompson on Twitter and the Elixir Slack if you'd like to reach out to me. Thanks for watching.